Welcome back to another video. Let's jump right into the topic of discrete uniform distribution. A discrete random variable is said to be uniformly distributed when all possible outcomes are equally likely. This means each outcome has the same probability of occurring. As for examples, we can look into a fair coin or a fair die. In case of a fair coin, there are two outcomes, heads and tails, and each has an equal probability of 0.5. In case of a fair die, there are 6 outcomes, 1 through 6, and each has an equal probability of 1/6. Since all probabilities are equal, you don't need a table or bar chart to specify the distribution. It's implied by the uniformity. We can generalize the probability mass function for discrete uniform distribution. If the values that our discrete random variable x cab accept are a plus 1, all the way to b, then the total number of acceptable values is b minus a plus 1. As a result, the probability for each individual acceptable value is 1 over b minus a plus 1. This formula ensures that the probabilities add up to 1 across all possible values. Please note that this is the general formula for all discrete uniform distributions. In order to define a specific discrete uniform distribution, the formula should be updated by specific a and b parameters. The population mean, also called the expected value, for a uniformly distributed discrete random variable can be calculated as the midpoint of the range of acceptable values. Mean is equal to a plus b divided by 2. This makes sense intuitively because, in a uniform distribution, the outcomes are evenly spread, so the average lies at the center. The population variance measures how spread out the values are from the mean. For a uniform distribution, the formula is variance equals to square of b minus a plus 1, minus 1 divided by 12. This formula counts for both the range of acceptable values and the fact that the probabilities are uniform. It provides a standard measure of variability for this specific type of distribution. For the case of a fair die, can you use the formula to find its probability mass function, mean, and variance? We know that in the case of a fair die, our random variable can accept values 1, 2, 3, 4, 5, and 6. As a result, a is equal to 1 and b is equal to 6. So our probability mass function is 1 over 6 minus 1 plus 1, which is 1 over 6. Our mean is 1 plus 6 divided by 2, which is 3.5, and the variance is 6 minus 1 plus 1 to the power of 2 minus 1 divided by 12, which is 2.92. Try to find probability mass function, mean, and variance for the case of a fair coin. Here you can see how we can use Python to calculate the PMFs and CDFs. We can use the randant function to model a discrete uniform distribution. Here as an example, I have calculated the probability of observing a 3, which is 0.166, and the probability of observing a 3 or less, which is 0.5. On the right side, we see how to use Python to visualize a discrete uniform distribution. Thank you for your attention, and see you in the next video.